OK, so for this problem, we have the sum of our n, all right? And we have 1 plus 2 plus 3 plus 4, dot, 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 dot to n equals n to n plus 1 divided by 2. Now, of course, we don't know if this is going to be true for every single number n, right? We are assuming that it's going to be true for every single number n. But we have not proven that it can be true for every single n. So what we're going to do is say, if we can prove this with k and k plus 1, then we know if it's true for k, then it can be true for n, right? Because k and n are some variables, so we can true them. So the first thing we need to do, though, is make sure that we can prove that our first term is obviously true. So we say s of 1 equals 1, which equals 1 times n, or 1 plus 1 divided by 2, which equals 2 over 2, which equals 1. Right? So we look at our first term. Does that equal 1? So we're good. Now, let's see if we can prove it for k. So we say s of k equals 1 plus 2 plus 3 plus 4, dot, 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 dot. K equals k times k plus 1. I'm sorry, not k plus 1. Yeah, k plus 1 divided by 2. All right? So now we're going to say, all right, if it's true for k, and our next term plus 1, is that going to be equal to k plus s of k plus 1? So we'll do, let's figure out what s of k is going to be. S of k plus 1. 1 plus 2 plus 3 plus 4, dot, dot, dot. The next term in the sequence is going to be k plus 1. That now has to equal our, again, I'm going to plug in k plus 1. OK? So now, to show that we have this working for us, we need to be able to show if, all right, if s of k plus the next k plus 1 term, if that's equal to s of k plus 1, then it's going to be true for all of our values. All right? And it's going to imply that all of our subsequent values on R will be true. So what I need to show is if s of k plus a of k plus 1 is equal to s of k plus 1. So s of k plus 1 is right here. So what does s of k plus 1 simplify to? K plus 1 times k plus 2 divided by 2. So what I need to do is I need to take s of k. Well, what is s of k? S of k is just k. Plus a of k plus 1 is just k plus 1 over here. A sub k Oh, wait, no, I'm sorry. What did I write? I'm sorry, s of k is not that. Jeez. I'm sorry, s of k is k right here. K times k plus 1 divided by 2. My bad. Plus k plus 1. Sorry. I was thinking, I'm like, how am I going to get my fraction? All right. So therefore, we have this. You guys understand? S of k is right here. Yes?
Why doesn't k plus 1 equal, why are we using the equation that it's equal?
We are. We're going to, right now, I'm just adding these two up. These two added up have to equal that, which is that right there. We are saying this plus this has to equal that. So s of k plus 1 is right there. That has to be equal to a of k plus 1 plus s of k.
So, but like why don't we use the equation for a of k plus 1?
I am. A of k plus 1 is right here. It's right there. I'm adding a of k plus 1 plus s of k. And s of k plus a of k plus 1 has to equal s of k plus 1. I am adding them. I'm taking s of k. S of k equals this. S of k plus 1 equals that. But it's s of k plus a of k equals this, is what we're trying to prove. Question?
What is ace of k plus 1 like?
Ace of k plus 1 is representing your next term,
No, what is
Yeah.
it equal? Like,
k plus 1.
okay.
So now, if we have our two fractions, we need to get them together. So I need to multiply by 2 over 2. So now we can get them to be together. So we'll have, let's see, we can multiply this to give you k squared plus k plus, that's multiply by 2, not square root of 2, plus 2k plus 2 all over 2. Well, here I can add this up into k squared plus 3k plus 2 over 2. Then, ladies and gentlemen, what you can see is this can be factored, right? This can be factored into k plus 2 times k plus 1, which you guys can now see is exactly the same as s of k plus 1. So therefore, it's true. We have it true for our values. Yes?
Why is k plus 1 squared?
Because k times k is k squared.
No. For the one next to it. Where it says k plus 1 in parentheses with a big, large 2 by it.
That's being multiplied because I had to combine these.
Oh, you're
Originally,
multiplying.
the problem looked like this. But to get them under the same denominator, I had to multiply by 2 over 2. OK? Any last questions?
I thought you were.
Sure.